Hi, I am Gurjeet Singh from Gill Instruments. I am a director and design head of this company. Today I am presenting here a very unique but simple liquid level gauge. This is a gauge which works with almost all type of liquids. It gives you high resolution liquid level measurement, but see, no wires. The base unit is mounted here, which is having only a power connection, and the sensor is on the other side. It is suspended inside the tank. So in the real life scenario, this base unit can be mounted away from the main tank. Maybe in industries there is a need, you have to measure the liquid level from the remote location of the tank, and your base unit will be installed in the pump house, or it will be in the control room. So it can work without wires almost up to 500 meters. So this level can be displayed in terms of percentage, or maybe in a volumetric way in the display unit. I hope you must be wondering what's inside this float. It's a floating technology, basically a smart sensor. So let me show you. This is what it goes inside this float. So basically this float is powered by our power MSP430 and CC1020, the wireless chipset. Both components are from Texas Instruments, and these two components are coupled with MEMS based accelerometer. So basically this goes inside the float on the side cap, and when your level is changing, you can see that the angle will be changing of the accelerometer. Change of angle in terms of percentage of the tank, or in terms of volumetric information that we are transmitting to this base unit. Now this is having one lithium battery. As you can see that here is a float, smart float, and as the level is rising step by step, each and every fine step is being transmitted and the level is displayed here. You can see here the level is right now 35%. So now it is defined. The moment it comes to 70%, automatically it will stop the pump. Now this level can be, by user it can be defined any level. Now if you look inside this float, you have a tiny hardware which consists of MSP430 2013, a very low cost 16-bit microcontroller, and the radio chip CC1020 along with a lithium battery. Now this whole assembly, it goes inside a float and it can work for more than 5 years, because it always goes in the deep sleep mode. Whenever there is a change in level, it will transmit the information to the base unit. Otherwise, it will always stay back in a low power mode. Now you can see here the level is rising. Right now it's a 59%. The moment the level will reach 70%, it will stop the pump. Now if you look at the sensor construction, it's very simple. This is the floating part, and on the another side, this is, we call it as a dead weight, which is suspended. So when your level is rising, the float will be rising, but that way it will stay there itself, and overall you will get 180-degree shift. So all the 180-degree we are converting into in terms of percentage. Now we can see here, yeah, it was set at 75%. So at 75% it will stop the pump. It can be used in food industries like in milk plants. It can be used in chemicals. And if you look at the construction of the float, it's extremely rugged float. It can be used in chemicals. It can be used in pharmaceutical industry. At last, thank you very much for Texas Instruments ultra low power technology for enabling us to make this happen. And thank you very much for TI MCU design contest team for giving us this opportunity to share our expertise with a wider audience. Thank you very much.